No mic, huh? Now I see you. How you doing?
Just setting up your equipment for you.
All right, thank you. Okay, well, we've still got a little ways to go before we have a test next Thursday, so not too much longer there, but let's talk about that for a few minutes, okay? Let me find my pen here. All right, so next Thursday, which is October 30th, I think we already said in here we'd have our test, so let's put that up here. We'll have our test. It'll be our second test. It's over Chapter 7. It's actually over 7.1 to 7.6, those sections. Okay. Oh, I thought I put it over there. I'm sorry about that. It's switching right now. Thank you. But you all heard what I was saying anyway, right? So, test next Thursday. That's all I've got up there so far. 7.1 to 7.6. And I'm going to give you some review problems out of the textbook to look at there. So to help, I don't know, just some extra problems. You all have some problems already, but here's some extra problems for review from the chapter review there. Over on page 499, numbers 1 to 31, 41 to 59, 73 to 89, 97 to 105, 113, 115. Okay, that looks like a lot. That probably is a lot of problems, but I'm just trying to throw out some extra problems for practice for you. You all also have the practice problems there from each class, you know, from each section that I give you each time to practice with. And I'm going to give you some more today from section 7.6. So you have those as well to look at. But just whatever you're doing, you want to have some practice there. All right, I don't know what's going on there. I'm working on it, yeah. So I'm working on it right here. I don't know what happened, so it's coming back. There we go. Okay. Okay. So anyway, we'll review with these. I want you to practice some more. You'll need a lot of practice in this chapter. That's what I'm trying to tell you. There's a lot of stuff in this chapter, as you've seen. It's taken us a while to go through a lot of material here. So does everybody have those problems? Now, those problems down. I'm going to look at some questions you might have had today from section 7.5, and then we're going to work on section 7.6 today to finish out there. On Tuesday, then, you know, you need to come with whatever questions you have, I guess, between now and then, or now and next Thursday. Let's try to get some questions going before that time happens. All right, so another thing, let me go over here to D2L just a moment. Well, we've just got plaid today and no picture. That's weird. There we go. I don't know what was going on. I've never seen that. let me go to your site. I should have had this pulled up, but I forgot I was going to use it. And we go to your site, down here to content, to handouts. There's one here called Trig Formulas. Okay. If I go to Trig Formulas, here's what I'm seeing. Sum and difference identities, that's what we've been working with, right? Those things there. Today in section 7.6, we're going to work with double and half angle formulas, so those will be there. And I'll give you a sheet like this on the test, okay? I'll give you this sheet, so a lot of you are breathing easier today, knowing that. So I'll give you that. You still have to know how to use the formulas, so practice making sure you know how to use them. Some of you may have already memorized some of the sum and difference formulas, but then we're going to add these others to it. I will also give you a blank unit circle again, okay? Because remember at the beginning of, even though we don't need that maybe as much now, well, maybe you do because you're finding the sine and cosine of pi thirds and all this stuff. At the beginning of the chapter, though, we were doing the inverse functions, you know, saying what angle has this as its sine or cosine. That might be really helpful there. So I'll give you a blank unit circle, and I'll give you a copy of this sheet right here. It's here for your reference so that you can look at it and see, you know, kind of this is what I'm going to be giving you. This is what you need to be able to use this to help yourself, okay? I still will not be given things like the tangent of theta equals sine theta over cosine theta. Okay, I'm not giving you that because you all know that, right? Okay, you're looking a little tired this morning. It's been a long week. Or maybe it's just me. Maybe I just think it's been a long week. I don't know. It seems like it's been a long week already. So let's go over to page 481, 482 and see the problems you were working with over there for a minute. Just kind of look back at the sum and difference formulas, and we added some things from that section to it last time. The ones starting down with 33, 35, 37, I think, where we had to draw the pictures. We looked at how we were going to draw those pictures and do those. Let's go back in and maybe do one of those or so. Maybe you have some from elsewhere as well. I don't know. Anybody have one you want to ask us about up here? You want us to look at? Yes.
Number 33.
Okay, number 33. So let's go to 33. We have the sine of alpha is 3/5. And 0 is less than, alpha is less than pi halves. And then we have the cosine of beta is 2 square roots of 5 over 5. And negative pi halves is less than beta is less than 0. And was it a particular part, or does it matter which part?
C.
Part C, okay. Part C wants us to find the sine of alpha minus beta. Okay, that's what we're looking for there, is the sine of alpha minus beta. Now we know that the sine of alpha minus beta, so like if you were using that sheet, you might go over there and look at that, you know, the sheet I showed you a while ago that I'll give you. But you're going to have sine alpha cosine beta minus cosine alpha sine beta for the formula there. Okay. All right. Now, what do we have? What do we need? We have the sine of alpha, which is going to go there. We have the cosine of beta, which will go there. We still need the cosine of alpha and the sine of beta. We need to find those things, okay? All right, this is why we're going to draw pictures so we can look at the angles, look at what we have, figure out the rest of it. So let's draw something about alpha. Which quadrant is alpha located in?
First.
Yeah, first quadrant. This tells us right here we're in quadrant 1. So alpha's over here in quadrant 1, and the sine of alpha, we know that's y over r. So y is 3 and r is 5. So what's x? X is 4, right. This is a common Pythagorean triple, 3, 4, 5. Okay, remember that one? 3, 4, 5 is one of the common ones. 6, 8, 10, 5, 12, 13. So if y is 3 and r is 5, then x must be 4. If you're not sure about it, you can do the x squared plus y squared equals r squared and get there. But the part we needed from this was what is the cosine of alpha, and the cosine is going to be then x over r, or 4/5. Okay, that's what we've got there. Because we needed that because that's what's going to go there here in a few minutes. Now we also need the sine of beta. So let's draw beta, a picture about beta here. Angle beta, where's that going to be? Fourth quadrant, right. All right, so the cosine we know is 2 square roots of 5 over 5, and cosine is x over r. So I'm going to label that x is 2 square roots of 5, and r is 5. This is not a common Pythagorean triple. Okay, so we'll go ahead and use x squared plus y squared equals r squared. And so what's 2 times the square root of 5 squared? We got what there?
20.
20 plus y squared is 25. So y squared is 5 when we subtract 20. And y is going to be what? Negative square root of 5, right? Has to be negative because of where we are here. Right, we had to go down since we're in the fourth quadrant. So always check about your positives and negatives. Okay, this one had to be negative because we're down in the fourth quadrant. And what we needed to know here, we were doing this part to find the sine of beta. So we see the sine of beta here then is negative square root of 5 over 5. Okay. All right, so we've got the sine of alpha minus beta is equal to, we're going to pick up all these pieces that we now have. Some of them were given to us, some of them were we just found. So we're going to plug them into the formula and figure out what the sine of alpha minus beta is. We don't know what alpha is, we don't know what beta is. We're just trying to see what the sine of the difference of the angles is. Okay. All right, sine of alpha minus beta then equals, the sine of alpha is 3/5. The cosine of beta was given to us also, 2 square roots of 5 over 5. And then we have minus the cosine of alpha, which was 4/5, times the sine of beta, which is negative square root of 5 over 5. So it looks like we have, for the first part, 6 square roots of 5 over 25 plus 4 times the square root of 5 over 25. And now we can put those two together because they both have the square root of 5. So we get 10 times the square root of 5 over 25. But 10 and 25 both have 5 in common, so we need to reduce that part. So 5 into 10, 2 times. 5 into 25, 5 times. So that's what it looks like we're getting there. Okay. Anybody have a question there so far?
Sorry, how do you simplify that?
Oh, how do I simplify the 10 and the 25, that part?
Yeah.
Is that what we're looking at? Okay, wait a minute until you get that part. All right, right here, this is 10 times the square root of 5, right? But the 10 and the 25, 5 divides into both of those. So we're just dividing them both by 5. Okay, we can't do anything with the radical part there because, well, it's underneath the radical, so it's kind of different. You know, it's a different type of term. Does that make sense?
Yeah, if we would like touch that or divide that at all. Would it still be right if we leave it unaffected?
Oh, if you leave it without changing,
Dividing the rest of the
you need to simplify. You always need to simplify your fraction, put it in lowest terms. Okay, so if there's common factors, we need to reduce it.
I just wonder why you're excluding that.
What am I excluding?
The square root of 5.
Oh, the square root of 5 Let me show you how it can cancel here. The only way the square root of 5 can cancel is if I have something like this. If I have the square root of 5 over the square root of 10, then I can say that leaves me down here with the square root of 2. So I'd have 1 over the square root of 2. Because a radical term, a square root, can only cancel with another square root. It's not going to cancel with a non-radical term. Does that make sense? So I'm not excluding it per se. It just, I'm not allowed to touch that part. Okay. It's kind of like this. Okay. It's like this. If I had, what did that say originally? If I had this, it's the same idea, except that square root of 5 is in place of the x on what we were looking at. But, you know, if we had this, then we'd change it to 2x over 5. Right? I think that one's worse with the radical because it has a 5 when we're dealing with 5s. So that's a problem there. But overall, we want to treat it like, you know, like x. We can't do anything with the x with the numerical parts because they're not like terms. And essentially, that's what's happening with the radical. It's not a like term. All right, were we finished with that part? Finished with that one? Any other parts of that one? Actually, while we're on that one, why don't we do the tangent part of that? Okay, because the tangent tends to be a little more involved on some of these. Let's go ahead and do the tangent because we got the information right here. Part D said to find the tangent of something. I can't remember now. Alpha minus beta. There we go. Tangent of alpha minus beta. And that will be the tangent of alpha minus the tangent of beta over 1 plus tangent alpha tangent beta. That's the formula we're using there. We will need to know the tangent of alpha and the tangent of beta. So to get those, I'll need to look back at my previous screen here. So I'm going to put here that I'm looking back on that previous page. Are you ready to look back? No, some of you are still writing. So look back at our graph here. What's the tangent of alpha going to be?
It's 3/4.
It's 3/4, right? So I'm looking at the alpha part. I've got y over x, so it's going to be 3/4. So the tangent of alpha is 3/4. What about the tangent of beta? Okay, negative square root of 5 over 2 square roots of 5. Okay, what about that though?
It can be reduced to -1/2.
Yeah, so it's just -1/2. So there I am going to cancel because they're both those square root of 5s. One in the numerator, one in the denominator. Now I'll plug into the formula. Okay, and we have the tangent of alpha minus beta is equal to 3/4 minus -1/2 over 1 plus 3/4 times -1/2. Just plugging in the things that we've gotten from the graph or from the information that was given to us. And now we're going to try to simplify this part here. I see we have 3/4 plus 1/2 over 1 minus 3/8. I can multiply everything by a value to get rid of the fractions. I can multiply everything by that least common denominator, or I can get common denominators and combine. Either way, so it's kind of two choices what we can do here. I'm thinking last time that you all kind of liked multiplying by the least common denominator to clear those out, maybe. So let's try that here. What's my least common denominator? Okay, we had 3 choices, right? They have all been said now. Which one is it? 8. The least common denominator has to be a value that all your denominators will divide into. Does that make sense? So they'll all divide into 8. So we've got 8 we want to multiply by. Now, 3/4 times 8, what's that going to give me?
It's 6/8.
Okay.
Oh, no.
Just 6. Just 6, right? You see what's happening there? All right. I'm not sure everybody's seeing what's happening. I'm going to write another step now. If I've got everything multiplied by 8, here's what's really happening, isn't it? Isn't that what I'm really doing if I'm multiplying everything on top by 8, everything in the denominator by 8? I'm distributing. So I'll write it out this way so that we can see what's going on, so I can cancel there. That's happening, this is happening, and that's happening, right? We wrote that 8 out there to multiply by so we could cancel all those denominators. That was our objective of doing that, okay? So if we multiply everything by the least common denominator, everything in the numerator, everything in the denominator, then we'll get rid of those extra denominators, okay? So up on top, we've got then 6 plus 4 over 8 minus 3. So that's going to be 10 over 5, which is 2. Okay. So it looks like we're getting 2 there. Any questions so far?
Where did you put 1/2 on the bottom here?
Do the, which part?
On the 1/2.
1/2 times 8?
So we cancel each other?
You're talking about this part here? Where I just marked through it more?
Oh, never mind.
Okay. Is there another question there? Okay. What else from this section 7.5? Somebody have something else you want to go back and look at there?
Number 37 for D.
Okay. 37D. Oops. All right, so 37, we had sine of alpha is 5/13. We have -3/2 pi is less than alpha is less than -pi. I keep writing the wrong thing down. All right, and tangent beta equals -square root of 3. Pi halves is less than beta is less than pi. Okay. All right, so we have then, let's draw alpha stuff, okay? On 37D, though, what we're trying to find out is the tangent of alpha minus beta again. That's what we're looking for. So we're needing the tangent of alpha, and we already have the tangent of beta, so that's reducing the work, at least on this part of the problem, a little bit. Okay, so tangent of alpha minus beta. We know the sine of alpha is 5/13. Where's alpha located? In which quadrant? Between -3/2 pi and -pi. Where would that be? -3/2 pi and -pi. Where are we? Second quadrant, right? Second, they gave it a little different. -3/2 would be here, if you're going around there, and -pi would be there because we're going in that direction for the negative values, right? So we're in the second quadrant. Okay, so that's alpha. And we know the sine is 5/13, so y is 5 and r is 13. That means x must be what? -12. Good. It's a 5, 12, 13 right triangle, and the x is going to be -12 there. Negative because we're over in that second quadrant. So the tangent of alpha appears to be 5 over -12, right? That's what we're getting, -5/12 there. Is everybody with me so far? Let's write out the formula for tangent of alpha minus beta. Tangent alpha minus beta, we've got tangent alpha minus tangent beta over 1 plus tangent alpha, tangent beta. Okay. Equals tangent alpha is negative 5/12 and minus the tangent of beta, negative square root of 3. So we've got that double negative going though because it's negative 5/12 minus negative square root of 3, so be careful there. And then in the denominator we've got 1 plus tangent alpha was negative 5/12 and tangent beta was negative square root of 3. Okay. So it's negative 5/12 plus the square root of 3 on top over 1 plus 5 square roots of 3 over 12. Well, let's get rid of the extra fractions, or you can change to the common denominator. I think that's what you were doing on yours, wasn't it? You were changing to it. Okay, so we've got negative 5/12. This time we're doing it like this. We're changing it to have the common denominator, so we've got 12 square roots of 3 over 12. Okay, we could have multiplied everything by 12, which actually might make it a little easier, but I think that you were looking at it this way, so let's put it this way. 12 plus 5 square roots of 3 over 12. Right? So far, so good? Okay. Now, here's where the problem was coming in. Okay. Up on top, negative 5/12 plus 12 square roots of 3 over 12 is just negative 5 plus 12 square roots of 3 over 12. We cannot combine the negative 5 and the 12. Okay? You see what I'm saying there? We cannot combine the negative 5 and the 12 because the 12 is with that square root of 3. And so then down here we've got 12 plus 5 square roots of 3, over 12. Still, we want to get rid of those extra denominators. We've seen this situation before, though, where we have the same denominator in the numerator and denominator of the big fraction, and we know those are going to cancel out. Or you can say, like we did before, we're going to multiply by 12 here and by 12 there to get rid of those. Okay. We could have multiplied by 12, remember, back in that first part of this last line. We could have. So now we've got negative 5. Whoops, that kind of, let's fix that. Negative 5 plus 12 square roots of 3 over 12 plus 5 times the square root of 3. So if you're checking your answer in the book, they're going to rationalize that. Sometimes they'll rationalize, sometimes they don't. I think they're rationalizing on this one. What do we multiply by here to rationalize this thing? 12 minus 5 square root of 3. That's right. 12 minus 5 times the square root of 3 is the conjugate of 12 plus 5 times the square root of 3. And we're multiplying by that conjugate to rationalize or get rid of the radical in the denominator. Now, here's where the fun begins. We have to multiply all that out. Okay, so up on top, I've got negative 5 times 12 is negative 60. And then the negative 5 times the negative 5 square roots of 3 will be plus 25 square root of 3. I have the 12 square roots of 3 times 12. That's plus 144 square root of 3. And then 12 square roots of 3 times the negative 5 on the square root of 3 will be negative 60 times just plain old 3, right? Square root of 3 times square root of 3 gives me the square root of 9, which is 3. So that's what I'm going to get with that part up there. Let me hold up there just a minute. We okay on top there? Is everybody okay on the top multiplication? Okay. Let's go to the denominator and multiply. Now this is where we're multiplying the conjugates, so what's going to happen is that outer and inner product are going to cancel each other here. That's what makes it work, right? So 12 times 12 is 144, And then we see, this part here and that part, they're going to be opposite, so they're going to cancel out. And I'm also going to have then the 5 square root of 3 times the negative 5 square root of 3 will be negative 25, again, times a normal 3, because square root of 3 times square root of 3 will give me 3. All right, so let's do the combining like terms and multiplication here and see what we get. On top, I see I have a 25 square root of 3 plus a 144 square root of 3, and that's 169 square root of 3, right? Then I have a negative 60 minus 180, negative 60 minus 180, it's minus 240. In the denominator, I have 144 minus 75. That looks like that's going to give me 69. Okay. Anything else on this one? See anything else? I think that's it. That's all we can do with that. Okay.
Is 240 divisible by 3?
240 is divisible by 3, but 169 is not. And in order to break this down any further with it written like this, we would have to have something in common with all 3 of these values here. Okay, I was trying to make that look like a triangle. It didn't really work for me. But 169, 240, and 69, all 3 would have to have a common factor in order to reduce it any further. And even though 240 and 69 are divisible by 3, 169 is not. So I think that's all we can do with this one. That's the answer the book got to, right? I mean, they went that far. So they rationalized. If on the test, and I say this mainly for the sake of time, because this stuff takes a long time to work out, on the test, that's fine. If you give me that right there, that's fine. Negative 5 plus 12 times the square root of 3 over 12 plus 5 times the square root of 3. It's what we had before we rationalized. Okay. We don't want those extra fractions in there. We don't want to leave fractions within the big fraction. But if you leave it like that, on one like this, that's okay. This is completely simplified here where the denominator's rationalized. Rationalize is a fancy way of saying get rid of the radical. Okay, that's all it's saying, get rid of the radical. So that's the process we went through down here where we multiplied and then, we ended up with no radical in that denominator. All right, what else there? Anything else on that part there?
29.
All right, 29. Let's do 29, then we'll move on to the new formulas here, okay? 29, we have sine pi 12ths, cosine 7 pi 12ths, minus cosine pi 12ths, sine 7 pi 12ths. So look at that. Look at what you've got there. And then I'm going to pull back up that formula sheet a minute. See, which one does this look like? Can you compare there with what you were working with? Let's look. It was minus. Yeah, it looks like sine of alpha minus beta formula, right? That's what we've got going. So it's sine of alpha minus beta. Okay. That's what it's matching up with. And it's looking like, that's alpha, that's beta. We've still got our alpha and beta there. So what we have then is the sine of pi 12ths minus 7 pi 12ths. What we're doing, this formula has already been expanded out. The problem is we don't know the sine of pi 12ths and the cosine of, 7 pi 12, all these values, we don't know, but we can condense it back into the formula. So the formula's already been expanded. We want to condense it back, whereas normally what we're doing, we're starting with the condensed version and we're expanding normally. So this is kind of the more odd thing to do with this, okay? All right, so we've got the sine of, what's pi 12s minus 7 pi 12s? Negative 6 pi 12s, which is really, so we've got the sine of negative pi halves. Sine of negative pi halves is going to be what? Negative 1. Yeah, you're allowed to do that. That's what we need to do on this, okay? So we actually need to do this process because it's expanded out, but what they're doing is trying to get that formula in your head with this type of exercise. Recognize that this is the formula for sine of alpha minus beta, and take your angle values and, subtract them, and then see what the trig function is for that. That's what they're looking for there. So you just see which formula it fits and go back into the, like tangent alpha minus beta, whichever one it is. Okay. All right, let's look at some other formulas here, because these other formulas are going to do the same thing that the sum and difference formulas were doing, which is giving us an exact value for an angle that we don't know about right off, not one of the common ones that we've worked with, like the pi 4s, pi 3rds, pi 6, pi halves. We know things about those types of angles, but we saw a lot of pi 12s kind of things in this section. We'll still see some of those in this section as well. But if there's an angle that we're working with that we can add or subtract two angles to get, then we can use one of these sum or difference formulas like we've been doing through just now, okay? If there's an angle that is a multiple 2 times something we already know about, then we can use a double angle formula. Or if the angle is half of something we already know about, we can use a half angle formula, okay? So the exercises they're going to have you work with in here, in this section, we're going to see how to work with these formulas. But first we're going to look at just what the formula says, and then we're going to apply it to the problems like we were just doing, where we were drawing alpha, drawing beta, seeing what we get for those, and see what we can do. So we're going to extend off of that. First thing is, well, let me put this as a new section, 7.6. First, I'm just going to start with the double angle formulas, even though the chapter is actually called double angle and half angle formulas. Okay. All right, so in section 7.6, and these formulas are over on page 484 for the double angles. Okay. We have the sine of 2 times theta. Sine of 2 times theta, it's double the angle, right? It's going to be 2 times sine theta cosine theta. Not a bad formula there. It's not bad for us to work with. Cosine 2 theta. You don't want to get this one confused with something we've already used, but cosine squared theta minus sine squared theta. Yeah, we know cosine squared theta plus sine squared theta is equal to 1. We've been using that a lot. Now we've got cosine squared theta minus sine squared theta is going to be the cosine of 2 theta. But the deal here is the cosine of 2 theta, we could use, there's other ways we can write it, okay? Because cosine squared theta is the same as 1 minus sine squared theta, right? And then minus this sine squared theta, we could write this as 1 minus 2 sine squared theta, or we put those together. That's another way of looking at the cosine of 2 theta. Coming from where cosine squared theta is 1 minus sine squared theta. Another thing we could do where it says cosine squared theta minus sine squared theta, that's the same as cosine squared theta minus 1 minus cosine squared theta, which would be cosine squared theta minus 1 plus cosine squared theta, which is 2 cosine squared theta minus 1. That's another way of looking at the cosine of 2 theta. So we could say, we got that from that cosine 2 theta formula there that we started with. So the cosine of 2 theta could be written 2 cosine squared theta minus 1. So for the cosine of 2 theta, we've got this one, and this one. Okay. All of those are for the cosine of 2 theta. You can use any of them. It's your choice. Does it matter? No, it doesn't matter. You're still going to get the same thing. They're just all built off that cosine squared theta minus sine squared theta, right? So maybe you're just given the sine of the angle and you want to know what the cosine of the double angle is. Then it would make sense to use the formula that just has the sine in it, right? So it could save you a little work there, I guess. And then we have the tangent of 2 theta. That's going to be 2 tangent theta over 1 minus tangent squared theta. 2 tangent theta over 1 minus tangent squared theta. And that particular formula is actually over on 485 in your textbook. All right, these are not going to be too bad for you to use. These double angles, they're probably going to be kind of a relief, less work overall from what we've been working with, the sum and difference formulas. So these are going to be a little bit maybe of a breather, I guess. Let's try one here with an example, okay? So over on page 491, I'm going to use number, what number? Let's use number 8 there. It says the cosine of theta is equal to 3/5. 0 is less than theta is less than pi halves. And part A tells me to find the sine of 2 theta. Okay. So we said that the sine of 2 theta is equal to 2 sine theta cosine theta. So what do we need to do to work with this formula? Yeah, we got to find the sine of theta. So how are we going to do that? Yeah, I like to draw a picture, okay, just to make sure we're visualizing it. Some of you already, you got it. So we see where theta is located. Theta is in quadrant 1. We know the cosine of theta is 3/5, so that tells me x is 3, r is 5. And that also tells me then that this is that 3, 4, 5 right triangle, so y has to be 4. Telling me also then that the sine of theta must be 4/5. Okay. So I have then the sine of 2 theta is equal to 2 times 4/5 times 3/5. 2 times 4/5 times 3/5. And we'll just multiply that out then. What do we get? 24 over 25. Good. That's the sine of the double angle. Okay, that just means we're taking that angle we started with, we're doubling it and seeing what the sine value is. So if I double an angle that's in the first quadrant, where would my angle end up at, the new doubled angle? Not the fourth. Okay. Think about angles in the first quadrant. Some of them, if I double them, they're going to end up still in the first quadrant, aren't they? If I take a 20-degree angle, double it, I've got a 40-degree angle, I'm still in the first quadrant, right?
This will be in the second quadrant. This will be in the second quadrant because it's almost a full number. That'd be 180 degrees, wouldn't it?
Okay, well, we don't know exactly where it is, but because they didn't tell us what the angle was, and we hadn't really seen, how to get, we could get the angle in radians like we've been doing with the inverse functions. We could do that, or in degrees on the calculator. But even not knowing what that is, if it's a smaller angle, if it's less than 45 degrees and we double it, we're still going to be in the first quadrant, right? But if it's larger than that, we're going to move it to the second quadrant. Is it going to be able to go anywhere past the second quadrant when we double it? No. Because the largest it could be, in the first quadrant is like what? 89.999, right? So doubling that, we're still going to be near that 180. Okay, so it could double and be in the first, it could double and be in the second. The only reason I'm asking you this is because, remember, we're saying that the sine of the new angle, whatever it is, we don't care what the angle is right now, but the sine of the new angle is 24/25. Does that make sense that it would still have a positive sine value? It has to, because we're in the first or second quadrant, right? It just works out for us anyway, but I just want you to kind of think about what we're looking at here. Let's look at the cosine of 2 theta. Which formula do you think you want to use? Anybody have a preference? We've got the cosine and the sine, so I guess we can just go ahead and use cosine squared theta minus sine squared theta. That actually might be the easiest one to use on this one because you don't have to deal with the one involved with that, the fraction. So I'm going to put up here the cosine squared theta minus sine squared theta. And I've got all the information here, so I just need to do 3/5 squared minus, the sine over there was 4/5 squared. I lost it for a minute. Equals, we have 9/25 minus 16/25 equals what? Negative 7/25. So when we double this one, we are ending up in the second quadrant because we're getting a negative cosine and a positive sine for that. Okay, yeah.
We wouldn't use 24/25 because it's sine.
That's the sine of 2 theta. Sine of 2 theta was 24/25. Okay, so since the sine of 2 theta is 24/25, we don't use that in this calculation for the cosine of 2 theta because the formulas are only based on the sine and cosine of theta, not of 2 theta. Okay, and it doesn't ask us for the tangent of 2 theta, but we're going to be overachievers and find that too. Okay, so let's find that one also. 2 tangent theta over 1 minus tangent squared theta. So what is the tangent of theta?
4/3.
Yeah, back up from up there. Well, not really from the sine, but the tangent of theta is 4/3 based on our information that we were given. So we've got 2 times 4/3 over 1 minus 4/3 squared. So we got to simplify that. How are we going to simplify? I can't multiply everything by 3 yet. Why? Because of that being squared down there, right? So maybe simplify that part first, and then let's see if that's what we want to do. On top, I may as well go ahead and multiply here and get negative 8/3. Oh, it's not negative. I saw a negative in my vision. It was an equals. All right. So we have 8/3 over 1 minus 16 over what?
9.
Yeah, 16 over 9. So now what do you want me to multiply by? By 9, right. If you're wanting to clear out those fractions, let's multiply by 9. So we're going to get 24 over 9 minus 16 equals 24 over negative 7. Did I have to use that formula, tangent 2 theta, to get the tangent of 2 theta? No, what could I have done? Okay, I could have taken my sine of 2 theta that I got from part A and divided by the cosine of 2 theta that I got from part B, because still the sine divided by the cosine will give me the tangent, right? So there I could use those new values to get the tangent, because as long as we're talking about the tangent of 2 theta, I can use the sine of 2 theta divided by the cosine of 2 theta, and I would have still gotten negative 24/7. My 24 does not look like, I don't know, I don't like the looks of the 24. Is that better? So once you've got the sine and the cosine, you could just use those to get your tangent instead of using the formula. Or you can use the formula, okay? So we just want to think about different ways to get there, I guess. Different ways. Go ahead.
What quadrant did you say?
We were looking at the first angle, the original angle, theta, up here. We knew it was in quadrant 1 because of the information we were given. But 2 theta, when we double it, you know, we said depending on the size of angle theta, any angle in the first quadrant, it could end up in the first quadrant, it could end up in the second quadrant. This one is ending up in the second quadrant because we see that the sine of 2 theta is positive, but the cosine of 2 theta was negative. So that meant we had to go, you know, over to the left and then up. These formulas are not too bad for the double angles, are they? Not too bad. No. Any questions about those so far? We need to look at the half angle formulas, though. They're a little bit more involved. So let's go over to the half angles. Now, these are the ones we're going to use if we are working with an angle that's half of something we already know about. And they are going to be over on page 488. We're going to use the sine of alpha over 2, and that is plus or minus the square root of 1 minus cosine alpha over 2. All right, you already see these formulas are a little bit more, maybe more intense because they have the square root there. They also have plus or minus. Your answer is not going to be plus or minus. You have to figure out which one it's going to be. Is it going to be a positive value or a negative value? We didn't have to figure out the signs on our answers for anything else. On the double angles, it works out for us. On the sum and difference formula, it just works out in the process. Here, we're going to have to decide, you know, will this sign value be positive or negative based on where the angle will be located. We'll look at an example here in a minute. The cosine of alpha over 2 is equal to plus or minus the square root of 1 plus cosine alpha over 2. And again, if you had the sine and the cosine, you would know what the tangent was, but we do have some formulas for this. The tangent of alpha over 2 is the square root of 1 minus cosine alpha over 1 plus cosine alpha. All that is under the radical. Okay, all of that is under the radical. But also we have other formulas, this time for the tangent of the half angle. 1 minus cosine alpha over sine alpha, and sine alpha over 1 plus cosine alpha. All those are formulas for the tangent of alpha over 2. Again, it's like that cosine of 2 theta. Take your pick. You can use whichever one you want, or you can just take this, what you got for the sine divided by the cosine, right? That's an option as well. Go ahead, Tom.
For the second and third formulas for tangent, are those also under the square root or no?
They are not. The question is, for the second and third formulas up there, are they under a square root also? And the answer is no. Only the first one's under the radical. The other two are not. So yes, if I was taking my pick, I would use one that was probably not under a radical. And save a little bit of trouble, I guess, there. We always try to go for the easier looking formula, right? So it's good sometimes to have choices on that. So on the same one we were just looking at for the double angles, let's see what we can do with that to finish out these half angles, and then we'll look though at a specific angle that we've got and work with, okay? So it's still on number, which one was it? Number 8 from page 491. Part C asks us to find the sine of theta over 2. Okay, our information was back here. Let me just put it back up over here. Cosine of theta was 3/5. 0 is less than theta is less than pi halves. We've already seen that that meant that theta was in the first quadrant. X was 3, R was 5. We know Y is 4, right? We've got all that information. Now, first thing we have to do if we're working with a half angle formula is we actually need to look and see where will that half angle end up at. We didn't really have to look at that for the double angle. I was asking you questions about that, but it's all going to come out okay in the formula. But here we want to know, where is the half angle going to be? If the angle itself is located in quadrant 1, as it tells us here, where will half that angle be?
Quadrant 1.
It will still have to be in quadrant 1, right? It has no choice. It'll be in quadrant 1. So we know that the half angle will also be in quadrant 1. Now, the reason we have to know that is because on these formulas for the sine, well, any of those really, sine, cosine, or that first tangent formula, we have to decide, are we going to use the plus or the minus? Since we know the half angle is going to be in quadrant 1, what does that tell me about the sine of the half angle?
It's going to be positive.
It's going to be positive. So we don't have to leave that positive sign there, but I'm going to put it there just to make us remember that we thought about that, okay? We thought about, is it going to be positive or negative? It's going to be positive because we've already decided the half angle has to be in quadrant 1 also. All right, so we've got positive the square root of 1 minus the cosine, and it's the cosine of the original angle, the cosine of theta in this case. The cosine of theta we know was 3/5 over 2 there. So 1 minus 3/5, what's 1 minus 3/5, or what are you going to do with that?
You got a 2/5.
Yeah, you've got 2/5. Okay, so you're just going to subtract it, right? 1 minus 3/5 is 2/5 over 2. That means the square root of 2/5 divided by 2 or times 1/2. That's going to be the square root of what? Okay, 2 over 10 or 1/5. So what's that going to be? So, okay, right. 1 over the square root of 5, rationalize. We get square root of 5 over 5. Okay. That's what we're going to get there, square root of 5 over 5. The half angle formulas are a little bit more involved than the double angle formulas, just a little bit. Questions on that part there, what we just did? Well, let's do the cosine. It's going to be very similar. The formulas are very similar there. So the cosine of alpha over 2 is going to equal plus or minus the 1 plus cosine theta over 2. So is it going to be positive or negative for what we're working with here? Positive, because we said the half angle is going to still be in the first quadrant, so it's going to be positive. If we had said it was going to be in some other quadrant, then, if it was going to be in the second or third quadrant, the cosine would be negative. So that's what we're thinking about here. Where's the angle ending up at? All right, so we've got 1 plus the cosine of theta, 3/5 over 2. This is almost the same exact computation, isn't it? It's very similar. So we're going to have the square root of 1 3/5, which is 8/5 over 2, square root of 8/10 We're going to simplify 8/10 and get the square root of 4/5. We're going to simplify the square root of 4/5 and get what? Two over the square root of 5. And that'll be 2 times the square root of 5 over 5. All these formulas are fairly straightforward as far as what we're plugging in, how we're working with them. We're doing a lot of computation here. The bigger thing, though, on this half angle formula is you do have to think about where the half angle would end up being located, so you'll know what sign, positive or negative, to use for your sine and cosine and even your tangent. Now, in this case here, we wouldn't have to worry anymore about the tangent ourselves, because what would you probably do to get the tangent of the half angle? I'm guessing to get the tangent of this half angle, since you've got the other information, you'd probably just do this and put the sine over the cosine. Is that true? That gives you the square root of 5 over 2 square roots of 5, which just gives you 1/2. So it's always true that the sine over the cosine is equal to the tangent. That's not using those formulas, but that's always true here. They don't ask you as much about the tangent. I don't know why in this part. Any questions on this one we're looking at here? All right, let's look at another one here. Okay, these are similar to the ones we've looked at so far with this parts A, B, C, and D. I think it's very similar to when we did the sine of alpha plus beta, cosine alpha plus beta. They're giving us some information. We're drawing a picture. We're figuring out, on the half angles where the half angle would be located. Okay, what if the original angle, let me ask you this, I guess, first. What if the original angle, theta, if we've determined that it's in quadrant 2, where's the half angle going to be?
It'll be another quadrant 1 or 2.
Okay, you say 2 or 1, you said 2 or 1? And then I hear 1. It'd just be 1, right? If an angle ends up being, if the terminal side ends up in quadrant 2, then the smallest it's going to be is like just barely over 90 degrees, right? 90, just for the sake of argument, let's say 91, okay? Even though we know we've got some little pieces in between there. Half of 91 degrees, that's going to put me in the first quadrant. The largest it can be is, 179.999, whatever. I take half of that, I'm still going to be in the first quadrant, right? So if my angle's ending up in the second quadrant, then my half angle will be in the, what did I put 2? Why didn't y'all tell me that? If the angle's in quadrant 2, where's the half angle? It's going to be in quadrant 1, okay? I said 1, but I wrote 2. I don't know what you call that disorder. I'm sure that's some disorder, right? I don't know what. All right. What if the angle ends in quadrant 3? Where's the half angle then? Where is it? Quadrant 2, right? It's going to be in quadrant 2. What if theta is in or ending in quadrant 4? Oops, sorry about that. Theta's ending up over here. We take half of it, so that means, okay, theta's between, I don't know which way you're going to think, 270 and 360 degrees, or 3 pi halves and 2 pi. Between there, you take half of it. Where's it going to be? I've heard 3. I don't know. Are we in agreement?
Yeah.
This is what I've got. Theta is ending up between 3 halves pi and 2 pi. Here's a way I can check it, okay? I want to know where half of theta ends up, so I'm going to divide that theta by 2. If I divide theta by 2, I can divide my other boundaries here by 2. I'm going to divide all these by 2, in other words. I get 3 pi fourths is less than the half angle is less than pi. Where's that putting the half angle? It's putting it in quadrant 2, isn't it? It's putting it in quadrant 2. It looks like if we're ending up between 3 halves pi and 2 pi, then it's putting the half of that in quadrant 2. Can you see that with your values? If the angles say 280 degrees, right? To make it easy to look at, then we'd be at 140, quadrant 2, right? If the angles, what else do we want to use? 272. Where are we? At 136. Okay, we're in quadrant 2. That's a little harder to see. So actually our half angles from what we've got on our original, just our from 0 to 360 degrees, they're going to end up either in quadrant 1 or 2 up there. Okay, that might help when you're thinking about some of these. Let's do one on with the half angle formula. That's just a basic angle here. Let's do the cosine of 22.5 degrees. This is a different type problem. This is where I'm actually looking for the exact value for this trig function of this angle that I really know nothing about, except what I do know is that 22.5 degrees is half of 45 degrees, right? Isn't that the same as that? 45 divided by 2 is 22.5 degrees. My formula over here, let me put the formula back up for the cosine of the half angle. Remember, the cosine of the half angle was plus or minus the square root of 1 plus cosine alpha over 2. So that means for my problem here, I'm working with now the cosine of 45 degrees over 2. 45 degrees is my alpha value in my formula. Now, the good news about this part is it actually tells us the angle. 22.5 degrees, we know where that is. We know we're in the first quadrant. We know the cosine's positive. So we're going to have positive square root of 1 plus the cosine of what? Yeah, just the 45 degrees. Cosine of 45 degrees is what goes in the formula. After all, I want something in my formula that I know something about. I want to use something in the formula that I'm familiar with here. So I've got the square root of 1 plus, what's the cosine of 45 degrees? Square root of 2 over 2 over 2. What am I going to do with that? Okay, or I can multiply to clear the denominator, right? Still yet? I can multiply by 2 and multiply by 2 to clear out the denominators, or denominator, equals the square root of, what do I have on top now? 2 plus the square root of 2 over 4. I've got that whole fraction under my radical. That means that I've got the square root of 2 plus the square root of 2 over the square root of 4, which will be the square root of 2 plus the square root of 2 over 2. That's the exact value, since you were wondering, right? The exact value for the cosine of 22.5 degrees. We get answers that look kind of strange. Whenever you're working with these where it says, or you're working with an angle that you don't know about, you might think about a couple of things. One, we've looked at the sum and difference formulas. and we want to know, is this angle something that we can add or subtract angles we know about and get to, then we would use those formulas we were using before today. Okay, the sum and difference formula. If we have an angle like 22.5 degrees, we would want to okay, that's not going to be something we know about that we add or subtract, right? We wouldn't add and subtract angles we know about to get 22.5. We would think, is it 2 times something? Is it something I know about that's been divided by 2, been halved? And that's the case here. Does anybody have a question on that one? Well, all right, let's see. Let's do one more like that. Okay, I think we better see one more. Let's do one with the radian measure. Well, I don't know that we have time for 26 right now. We might have to come back to 26 next time. Let's do, where's one with radian measure? Right there, 21, 22. The tangent of 9 pi eighths. Okay. We're in the double and half angle section. They tell us in the directions actually here to use the half angle, so we're going to cheat a little bit and use that part that we know we're using a half angle. So if we're using a half angle, we need to know what is 2 times that. What angle did we have to get that? Looks like we halved 9 pi fourths, right? Can't get it to work out. We took half of 9 pi fourths to get 9 pi eighths. Let's write up the formula here. This was the one, no, this wasn't the one. It was, yeah, this was the one that we have 3 separate formulas we can use. So which one do you think we want to use? Remember those formulas? Let me put them back up here. First one is plus or minus 1 minus cosine alpha over 1 plus cosine alpha. The other two, remember, did not use the radical. We had 1 minus cosine alpha over sine alpha. We had sine alpha over 1 plus cosine alpha. We only need to use one of them. What do you want to use? Does it matter? I don't know. Doesn't matter. One without a radical. Okay. Which one you want to go with? The second one? You like it? Let's go with that one. We'll say we're going to use this one. All right. So we're going to say then the tangent of alpha over 2. Well, not alpha. Our alpha is what? 9 pi fourths. Tangent of 9 pi fourths over 2 is going to be 1 minus the cosine of 9 pi fourths over the sine of 9 pi fourths. Where's 9 pi fourths? Where is it? 9 pi fourths. That's equal.
It's third quadrant.
9 fourths pi? What's 9 fourths equal? It's 2 1/4, right? So it's in the first quadrant, right? It's 2 1/4 pi. So this angle 9 pi fourths at least is in the first quadrant here. All right. We're trying to find the tangent though for 9 pi eighths. However, on this one, on this particular formula, we don't have to decide if it's positive or negative. Only those that have the radicals we have to decide. Otherwise, it should work out for us. Okay? Let's see what happens. The cosine of 9 pi fourths then is what? If we're ending at the same place as pi fourths, right? Does that help? Square root of 2 over 2. Down in the denominator, what's the sine of 9 pi fourths? Square root of 2 over 2. What am I going to do with this mess? Multiply by 2. That's a good process, isn't it, to use? Equals 2 minus the square root of 2 over the square root of 2. Since there's just one term down there, we could rationalize it, couldn't we? multiply by square root of 2 over square root of 2. We get 2 square roots of 2 minus 2 over 2. Well, that is going to simplify. So I can actually factor a 2 out of the top. And there's what we're left with, right in the nick of time here, right? I hope. All right, so let me put up here, I know some of you are still writing, but let me put up here what I want you to practice with from this page. Remember those practice problems you can start reviewing with for the test that I put up at the beginning of class? If you came in late and didn't get those, you'll want to look back at them. Okay, and we're going to try this 7 through 25 on this page just for practice in section 7.6, okay? Practice with those, and you've got practice problems for next week's test, okay? Any questions? You'll want to look back over this. We'll do a few more of these at the beginning of class next time, as well as any other questions you have, 7.1 to 7.6, okay? Are we good? Any questions? Okay, everybody's ready to go. Have a great day then, and a good weekend too. It's almost weekend for you guys, for this class anyway.
Jamie,
Yeah.
do you use any of the advanced math or 3D functions on the smartboard?
Do I use 3D functions? No.
Or the advanced math functions? You just draw on it, right? That's all you do?
I just draw on it, yeah, thank you.
Yeah, okay, good.
I just draw on the smartboard. Yeah, I don't have to use anything else. Just something to write and see.
Okay, well, you got that then. The other two haven't been installed, and it takes a while, so I won't worry about those.
Okay, we'll be in good shape then. Thank you.